Area. Our objective in this lesson is to be able to use formulas for area of two-dimensional objects to solve real-world problems. Area, which could be used by the abbreviation capital A or capital B. Notice that it is capital A and not lowercase a. Area is the space covered in two dimensions. Area is two-dimensional. Think of, instead of line, the space when I color something in. That's an area that I'm covering. The units we use, because it's two dimensions, will all have square in them. Square centimeters, square meters, square inches, square feet, etc. Think of covering when you're thinking of area, such as instead of the fence around the yard, think of the grass in the yard, the grass that's covering the yard. Think of paint on a wall. It's covering the wall. Think of carpet. Carpet covers a floor, so carpet on a floor. These would all be examples of area because they cover a space. These are formulas from our formula sheet that we would use for area. Notice the capital A that we see in these formulas. Those represent area. Example 1. Find the area of the figure shown. Again, we have a regular hexagon. I remember that regular means all the sides are congruent. Therefore, all of these sides are 5 centimeters. I look at my formula sheet and I find the regular hexagon, and I look and I notice there are two area formulas. Because I'm only given a side length in my problem, I want to use the formula that uses the side length. So I'm going to write that formula. A equals 3 times the square root of 3 over 2 s squared. S is that side length, so that's what I'll plug in. 3 square root of 3 over 2, s is 5 squared, so 3 square root of 3 over 2 times 25, and simplifying that makes 75 over 2 times the square root of 3, and my units are centimeters. Because area is two dimensions, I do centimeters squared. That's the area of the regular hexagon. Number 2, again, is a rectangle, and again we remember the opposite sides are congruent. Looking at my formula sheet, here is the rectangle, and I see capital A for area. Writing the formula, area equals length times width. So the area will be 4 times 3, or 12 inches squared. Remember, area is two dimensions, so we always use the square in the units. Number 3, find the area of a 16-inch apple pie. I know an apple pie is the shape of a circle, and I need the area. So I'm going to look at the circle formulas. I see capital A for area, and I'm going to write the formula I need is A equals pi r squared. Now remember, for circles, that r is for the radius, while the d is for the diameter. We were given the fact that it's a 16-inch apple pie. That's the diameter. The diameter is 16. The diameter goes all the way across the circle. The radius only goes half of the way across the circle. So if the diameter is 16, the radius is 8. Plugging 8 into our formula, we get pi times 8 squared, or 64 pi. Because the units are inches, we write inches squared. Part B, what is the minimum amount of icing that would be needed to cover, remember that cover means area, just half of the top of the pie? That means I need half of the area. Half of the area I found in the previous problem, 64 pi, is 32 pi, and of course the units inches squared. Thanks for watching.